Hi guys, welcome to our technical webinar hosted by OpsWorks company. Today we have an amazing opportunity to talk about AWS VPC overlaps and how to solve them. I have an absolute pleasure to introduce today's speaker. Please meet Serhiy Kaidalov. Serhiy is a solution architect here at OpsWorks. He has a lot of experience. He has 8 AWS certifications, and he's honestly one of the best and most engaging speakers I ever met. So I hope both you and Serhiy will enjoy this event a lot. So yeah, that's all from my side. And Serhiy, the stage is yours.
Thank you. Thank you, Kate, for such a great introduction. Hi, my name is Serhiy Kaidalov. I'm solution architect at OpsWorks. I have 20 years of experience, 6 of them in AWS Cloud or in different other clouds as well, and 13 years plus I worked as a network engineer. That's why today's topic will be mostly about networking stuff, as you already understand from the naming. And today we are going to discuss the issue of overlapping networks or CIDR blocks in AWS, and maybe we will touch also on-prem point of view. And from my experience, usually like the average project begins from we need it quickly. It's like it will be temporary solution. Yeah, brainstorming is probably the later steps usually. So at the beginning, we need it quickly. We needed proof of concept. We need to start working. We need to start earning money, and so on and so forth. And then, as we all know, nothing is more permanent than a temporary solution. Usually, we end up in situation like this. But before I'll tell you how to deal with this situation, how to solve all these issues, before we jump into this discussion, I'll tell you about today's agenda. So first of all, we will discuss all the possible ways how you can end up in this situation. I'll teach you about the document you probably should implement in your organization or in your practice, because it will help you a lot in the future. And later we will discuss the use case of what we did for our customers, which end up in exactly this situation with multiple VPCs that had the same CIDR block. So no, it's a little bit too early. So how you can end up in this situation? There are a couple of ways. So first of all, it can be bad planning. So just as I described before from my practice, usually people tries to start business, tries to build infrastructure as soon as possible without any proper thinking about it, how it will go, how it will grow, etc., because we need to start from something. Probably we can start from a smaller VPC, like /20, I don't know, maybe something like that, or maybe we don't think about growing, etc. And then we will have like different accounts, different like multiple VPCs with the same CIDR block, because it's easy to just copy paste all existing resources into another account if you use, for example, infrastructure as a code without changing the CIDR block. And later we need to connect all of them together, and like, oops, that's the problem. Another way how you can end up in this situation is by acquisition. For example, you work in a company. That company acquired several smaller companies with already existing infrastructure. And I'll answer all the questions later. We will have like the answers and questions block, whatever. Yeah, and we will answer all the questions. So please, yeah, drop your questions in the chat. Kate will gather all of them later in the end of our session. I'll answer all of them, or at least I'll try to answer on all of them. So acquisition. So your company acquired smaller companies. You went to the way of consolidating all the resources, all the stuff, and probably you need to connect all the networks. I don't know, you want to have a single VPN, you want to have, I don't know, single internal resources, because different companies, different departments use the same tools in each VPC or in each AWS account, and it makes no sense. Maybe less licensing cost, etc. And all of these companies, or some of them, have overlapping CIDR blocks, and that's preventing you from the merging all together, establishing communication between them. Another option is when you connect AWS a cloud environment with on-premises environment. So initially you thought that your cloud environment will not interact in any way with your on-prem environment, but now something changed, like some environment variables has changed, and now you need to connect them, and oops, again, you have the overlap inside the blocks. Also, very possible solution that you're acting as a service provider and you don't control the VPCs of your customers or partners or whatever, and you need to expose some your resources internally without leaving to the public internet, to different account, to different VPCs. And again, you don't control the your partners' VPCs numbering, so you need somehow to connect them. And also possible solution is IP exhaustion. For example, really often happens with EKS. So you created a VPC, doesn't matter, it could be even /16, but you have really big cluster with a lot of workloads, and you don't have enough IP addresses because you're using VPC CNI, which attaches IP address for each pod in your cluster. So that's why you probably also may end up in situation when you don't have IP addresses. That's kind of not exactly about connecting, but about, again, VPCs. And we also will see how to avoid this, how to deal with that. But before I teach you the ways how to do it, the first, I already mentioned it, we need to have the document called ADR. So what is that ADR? So ADR stands for Architecture Decision Record. You can name it whatever you want, basically. It can be naming, it's not important, but basically you need to have the document which explains why the changes were made the way they are. So such a document may be useful in the future. For example, in 5 years, nobody knows anything about the infrastructure or the application what was built like 5 years ago, and you need to somehow, I don't know, improve it, like why it was built this way, why we did like these mistakes, why we use these technologies. And basically this document will explain you and help you. Or for example, you have a new engineer that starts working in your company and doesn't know anything about that part of infrastructure or about this application, how it was built, why it was built, what decisions were like made. So that is basically what it is. So this document outlines like the reason of the changes. Why do we need them? What was the driver of these changes? Then in this document, you should have decisions or solutions. So we decided to do it this way. We had also like trade-offs and solutions, like different kinds of solutions. So we have this solution, we had this solution, we had third solution. Also, you outline like pros and cons of each solution. And finally, you have the decision, what was like accepted, or if it was accepted, it may be not accepted. Then it also may have the architecture, like diagrams, maybe database schemas, maybe some other schemas like detailed diagrams, maybe not so detailed, but how the application will work or how this infrastructure will work, etc. Also, if you work with in in payment industry, sorry, or if you work in healthcare, or if you have the clients, you're gathering data of EU clients, so you need to be compliant with PCI DSS, you need to be compliant with HIPAA, you need to be compliant with GDPR. So you also should put security stuff in here, like what information will we gather, how we will protect it, etc., etc. So that document is probably the crucial part for the proper planning and to avoiding such mistakes in the future. Whew, let me just take a sip of water. Yeah, so moving forward. So what are the ways of solving this? There are basically 4 ways. You can combine them, you can create something new, which probably not really happening in the future. But basically, the option number 1, which I recommend, which AWS recommends, if you can, you should renumber your networks. Why? Because without renumbering, you will have very complex network. You will be managing very complex network. You will be probably having the NAT somewhere, NAT instances or NAT gateways or whatever. You will have a lot of the same IP addresses everywhere. Debugging or troubleshooting will be just like a big headache. You will have different compatibility issues when some of your instances behind NAT and don't support direct connection between other part of the networking. So basically, if you renumber your networks, it will reduce complexity of managing, reduce complexity of troubleshooting. So it will make your life much easier. But again, it's not free after all, because time and people cost money too. So you should invest, but in the long run, it will save you a lot of human resources, a lot of money, etc. By renumbering, I mean that you need to create a new VPC completely, basically. Option two, AWS Private Link. So it's a service that is provided by AWS. Basically, it helps you to publish endpoints of your application or API or just web endpoint via using network load balancer or something else. And you will have like interface endpoint in your partner VPC. So basically, it works like a VPC peering, but you exposing only one service at a time. What else about this stuff? Yes, it's basically NAT, double-sided NAT from both sides from AWS. Also, very useful thing, for example, for service providers, as I said. So if you don't control the network on the other side, that's probably the best solution for you. Because if you control all the networks, you should go with option one. If you don't, and you service provider, probably AWS Private Link is the best option for you. It's also secure because, as I said, it works in the like the VPC endpoint, VPC peering. So you send in the request, and end user or your end partner should accept it before any communication can be made. There are also some limitations, as usual not, but recently I saw the news that AWS supports voice over IP and SAP protocols for the private link. Maybe I'm wrong, but something about voice over IP is already supported for the AWS private link, and also UDP protocol is also supporting at the moment, if I'm not mistaken. Option number three, you can have multiple VPC, multiple CIDR blocks in your VPC. So basically, think of it as a several tier application. So you have backend tier, you have front-end tier. So backend tier will be stays in the overlapping subnets or VPC CIDR block, and the front-end application will be in a new VPC CIDR block. So front-end tier will have all communication will be seen from different VPC from all the other parts of your network, but backend tier will not be visible. It will have access to the internet through the night gateway probably, but there will be no direct communication with backend CIDR block. And option four, basically you can use private NAT gateway or any other NAT instance, whatever you will do, but you can use the private NAT gateway service was released, I believe, not so far ago. So basically it's NAT, and you're, again, the same as option three, but your private part of your subnets behind the NAT will not be visible in all your network, but that part of the network will have connectivity to other instances in your network. So that's basically four options that you can do to solve that issue. If you, again, the takeover from this, if you can, you should renumber your VPC, renumber network. If you service provider, probably AWS private link, the best option. If you can do first two, probably you will end up with option three or option four or mix something of them. Only option one gives you full routable network, full your devices, full your instances will see each other. All other options will not give you that possibility. And right now we go into the use case that we did for our customer. Before that, where you can find information I was talking about right now. So all these options, all four options described in this orange QR code, you can have the link if you scan it. So there are like all the information, what I just said, maybe with more details, but you have it. And the green QR code will guide you to the uh, topic or the blog post, again in AWS, how to deal with exhaustion of IP addresses in your when you're using EKS clusters. Basically, all the stuff. So for the EKS cluster, they have used option 3. So nothing new here, nothing new they did, but basically it's also useful, and you may find some interesting parts there, interesting information there. And now going to use case. So our customer basically acquired several smaller companies and decided to do the full network reachability. But as we know, we ended up with having the overlapping networks. So we created EDR, basically this document, as I talked about it. And in this document, we described why we want this, described two solutions. And here is the solution number one. Solution number one was simply to create a new VPC, additional CIDR block in your existing VPC, and move everything to new VPC. So solution is pretty simple, easy to implement, as you can see, and requires minimal or no downtime. What I'm meaning by that. So basically all the services that described here and that our customer has is RDS, EC2, except EC2, OpenSearch and Elasticsearch. They have a thing called subnet group, if I'm not mistaken. So basically, when you create your RDS instance, your Elasticsearch, and your OpenSearch instance, you need to create subnet group. And in subnet group, you specify the subnets of your VPC that will be used for creation, where your resources will be created. So you simply can add new subnets to this subnet group. Then by, for example, for JS, you can create new reader. It will be probably created in a new subnet. Then you fail over writer to reader. And in that way, you will move all your resources to a new subnets and then just remove your old subnets from the subnet group. So EC2, you can just recreate from AMI. That's kind of it. So that's why minimal or no downtime. But this one will always but. So it will be harder to maintain in the future because we will still have this default 10.0.0.0 slash, what do we have, the 2016 VPC. You cannot remove it because it's default VPC. You can add additional CIDR blocks, but you cannot remove the original CIDR block. You can remove additional, but not the original one. The main problem is that we are using, our customer are using transit gateway and want to use automatic route propagation. In this case, when you have two CIDR blocks, they all, or two or more, all CIDR blocks will be automatically propagated to your transit gateway. So if you want to prevent it, the only option you have right now in transit gateway, you need to specify them by hand. So you need to manage your routes by hand, which is not great, I believe. You can manage it with Terraform, but automatic propagation is better, what we decided. Also, this CIDR block 10.0.0.0/16 in our case will be not usable. What I'm meaning by that? So if, for example, we have on-premises data center which has this CIDR block, our new subnets, even if we move everything to new subnets with new IP addresses, will not be able to route, will not be able to reach to this the same CIDR block in the on-prem, because, well, it's kind of doable. You can create like specific roles like 10.0.0.0/17 and another one, and then traffic will be moving to the data center to transit gateway, but that's not what we want. It's, again, another like managing overhead. We want to avoid it. And these resources will have no IPv6 support. What I'm meaning about that. So when you create, for example, a case cluster in subnets or VPC that had no IPv6 CIDR blocks before you created the case cluster, even if you add VPC subnet IPv6 subnets later, EKS cluster will not be supporting them. So we decided we want to move to option 2 probably. Solution 2 is to simply migrate. So we will be using renumbering. So we decided migrate. Why? New VPC will be supporting IPv6 from the start. So if we in the future we want to migrate to IPv6, it will be possible easily without recreating a lot of resources such as EKS, for example. It will be easy to maintain in the future because we don't need to deal with old networks with overlapping and et cetera, et cetera. We don't need to have the static routes for different resources. Also, there was also interesting part. We can test Terraform setup from scratch because for existing infrastructure, we just imported, we described everything in Terraform and imported it. Right now, we will have ability to test it from scratch. So we tested it. We had disaster recovery. We had sessions. We destroyed resources we created with Terraform, but we never performed like complete recreation from scratch. The cons of this solution, harder to implement and prepare because we need to have a downtime. Probably we don't know for sure. It required a lot of efforts. It will be longer because again, by the contract, our customer should inform his customers at least 2 weeks in advance that we will have some downtime. And why we had the downtime? I'll tell you now. So we decided to go with solution 2. As you can see, there is like a simplified infrastructure. So we have our VPC initial, we have transit gateway, we connected this VPC to transit gateway. To that gateway also connected a lot of VPCs, but that doesn't matter right now. So what we did, we created completely new VPC in the same account. Created from Terraform, using Terraform, all the subnets, all the ACL, all the security groups, everything. So it's completely new, empty, prepared VPC. Then we created connection. We connected this VPC through to Transit Gateway, and also we connected it through the VPC peering. Why? Because part of our infrastructure, since we will be moving basically component by component, and the first component that we will move is database, we need to have lower latency between our database and the application. Transit Gateway introduces higher latency than VPC peering. That's true. Not so much, but we want to keep it as low as possible. So that's why we had another connection via VPC peering, temporarily, and before migration. So the first step was to migrate RDS. So we planned it beforehand. We announced that in 2 weeks we will have 2 hours of downtime. Why 2 hours? So we measured the best ways to migrate with downtime, without downtime, and probably the best way was to migrate using data migration service, but that was too expensive and too long. So we will have to pay for 3 instances of database, basically the old one, the data migration database, and the new one in new VPC. And it will take a long time, but without downtime. So we decided, we tested a couple of options, and the best option was to clone database to new VPC. It takes 8 minutes to completely clone the database and bring it up. So we put in 2 weeks after informing the customers, we put our application into read-only mode. We stop all transactions to the database. We created a clone, and in 8 minutes, basically, we were up and running. But we also decided to test everything. So the complete migration of RDS took 1 hour. Yes, not 2, but we decided to do it with additional time to be safe. So after migration of database, other services migration was pretty simple. EC2 were just recreated from AMI images, from snapshots, because we have all EC2 in redundant mode, basically. So we just shut down one, create image, move it, change the DNS, and one by one, all EC2 migrated during off-business hours. Elasticsearch, basically the same setup. We created snapshot, restored the cluster in a new VPC from snapshot, then we have the script that will seed the missing data from the database to Elasticsearch. So no problems there. The same with Elasticache. The only thing that we did it off business hours, so we had no downtime. Only visible impact was some customers were logged out from the system. That's it. And the last part, the most important, EKS cluster. So we created completely new cluster in a new VPC with IPv6 support, dual stack, everything. Created all the auxiliary components such as set manager, load balancer, AWS load balancer controller, all the stuff. Then we deployed all the applications for the customers. And then basically we switched the DNS, waited for the DNS propagation to complete. And after a day or so, we completely removed the old cluster and completely removed all the resources, removed the VPC peering, removed the VPC, and that's how we completely migrated with downtime into hours. Yes, project took approximately like 3 weeks and 1 month of planning, but we completed it in just 1 hour of downtime. And we, after that, we don't need to deal with all other stuff such as overlapping CIDRs, etc., etc., etc. So if you want to connect, you can. There is my contacts. You can add me on LinkedIn. You can send me an email. If you want to discuss, some networking stuff, or if your company need help with doing some networking stuff, welcome. We can help you definitely.